Okay, so let's go through the Kager typology of vowel nasality. And what you see up here is this is meant to be multiple tableaux that are simplified, where for vowels that are not before a nasal consonant, I have the input with an oral vowel, the input with a nasal vowel. And for vowels that are before a nasal consonant, I have the one with an oral vowel before a nasal consonant, and I didn't have room to put the fourth relevant tableau down here, which would be this one, but with a nasal vowel in the input. The reason why I use this one with the oral vowel is because it's going to be the more problematic candidate with regard to the context-specific faithfulness constraint. We want to see how this one patterns, and I'll talk about the fourth candidate as I derive each of these languages. I don't have room to put it on my home blackboard here. Of course, all the tableaux with all their details are in that Kager chapter where he talks about the typology predicted by these three kinds of constraints, as we did for fricative anteriority and vowel quality in the earlier part of this lecture. So how is this going to work? Well, we think that based on these three kinds of constraints, we're going to end up with 4 different possible languages, just as we did in the earlier example with vowel anteriority. And we have a ranking recipe for producing each of these patterns. And so the question is just, what would those patterns look like? Well, let's start with the first one here in the list on page 6. Lack of variation, where you just have an inventory restriction. And you get that from ranking the context-free markedness constraint high, and it doesn't matter what you do with the other 2 constraints. As long as the high rank constraint is the context-free markedness one, you're just going to get neutralization everywhere, because the most important goal in that language is going to be to avoid some kind of marked structure. So out of the 3 constraints that Kager gives here, the context-free markedness is going to be star nasal vowel, because that just says, hey, for any particular one sound in a language, don't let it combine plus syllabic, minus consonantal, and plus nasal. Why did I put minus consonantal in there? Because in a theory where you have syllabic nasal consonants, you might want to allow those while disallowing nasal vowels. And so we're going to treat nasal vowels different from nasal consonants. And you could have a nasal that is the head of a syllable, potentially in a language like English. You might have syllabic nasals that aren't vowels, and that's going to be treated differently from nasal vowels. That's why I would put that minus consonantal in there. That would not apply in that case to syllabic nasals. But we're just going to abbreviate this star the nasal as Kager does. Right. And in order to know how this system works, all you need to know is what this high rank constraint does. I've only included the minimal candidate sets here that are dealing with changes in vowel nasality, because these are going to be sufficient to see the predictions of the system. Again, in a real serious analysis, you'd need to consider all sorts of other repairs, but for the purposes of this typological illustration, all we need to think about here is the nasality or orality of a vowel. And so for each one, I've just listed output candidates here that are oral vowel or nasal vowel versions. And of course, what this markedness constraint is going to do is eliminate all of the candidates with nasal vowels, regardless of what the input is. And of course, if I put a nasal vowel in here as the fourth candidate, the fourth relevant input would be, it's still going to work exactly the same, and it doesn't matter at all what happens with these 2 lower rank constraints, which I haven't even filled in yet. As long as this one's ranked high, it's always going to destroy all the candidates that have nasal vowels in them. The outputs are always going to be oral vowels. Right? So input pa maps to pa, input pan maps to pa, input pan maps to pa, pan maps to pan, and input pan that's hard to say, pan maps to pan, just like this one, right? So there's never any nasal vowels in this language, and at a first pass, that's going to be like probably most varieties of Spanish, although be very careful there, because in some varieties of Spanish, you do get nasalization of a vowel before a word final nasal. It's going to depend on probably how fast you're speaking and where you're from. But in some varieties of Spanish, at least, you have roughly this pattern where vowels remain oral even when they're before a nasal vowel, right? So that's just an inventory constraint, excuse me. Don't have nasal vowels, right? This language just doesn't allow nasal vowels, period. Right? Next pattern in our sort of recipes here is allophonic variation, complementary distribution, allophony. These all sort of mean the same thing for the purposes of this class. What is that pattern going to look like? Well, first let's get the ranking recipe. Here we need to have context-sensitive markedness ranked above context-free markedness, and both of them ranked above faithfulness. And so some sort of gross properties of this ranking, right, is all the markedness constraints are ranked above faithfulness, so you're not going to get contrast anywhere, because remember, faithfulness constraints preserve contrast, or favor preserving contrasts. Markedness constraints favor destroying contrasts, right? So if we have all the markedness constraints ranked above all the faithfulness constraints, there's going to be no contrasts for the feature in question anywhere in the language, and that's going to be true in allophony or in complementary distribution. But the fact that the context-sensitive markedness constraint is the highest priority in a language like this, even more so than avoiding features we don't like, that means that we're going to get variation depending on the phonetic context. So let's see how that works. We're going to change this to our context-sensitive markedness constraint, which is don't have an oral vowel before a nasal consonant. And I'll abbreviate this again like Kager does. I'm just going to abbreviate this star V oral N. In formal terms, you'd want to formulate this as star plus syllabic minus nasal, and then a separate bracket that says plus consonantal plus nasal or something like that. But that's what this is standing for. It's a shorthand. And the other things we needed here were the context-free markedness constraint ranked immediately below that. Otherwise, if you're not before a nasal consonant, then don't have nasal vowels. Right. And then the lowest rank constraint here is going to be the one that preserves vowel nasality. If we were able to preserve input vowel nasality, then we'd have a contrast. In this language, we don't. So that must be a pretty low priority constraint. So ident nasal. Okay, how's this going to work? Well, for these guys, where there's no nasal consonant anywhere in the input, this context-sensitive markedness constraint is going to be totally irrelevant. Right? There's no nasal consonant in here, so there's no way to violate this constraint unless you added a nasal consonant, which we're not going to do. This one, the context-free markedness constraint, then takes over in this case where you don't have any nasal consonants, and it does the same thing it did in the inventory restriction language. It just says, hey, get rid of the nasal vowels. So we're going to get only oral vowels in these contexts. For this one, things get a little bit complicated now. We have a nasal consonant, right? That matches this. Is the thing before it an oral vowel? It sure is for this candidate. So here, context-sensitive markedness takes over. And we get a reversal. We get nasal vowels before a nasal consonant. And of course, even if this input had a nasal vowel in it, that's the fourth tableau I couldn't fit here, this would look exactly the same. It would say this guy's bad and this guy's good, and you'd end up with the same output regardless of vowel nasality in the input, right? So no contrast can surface anywhere in the language. But it's going to surface, the value of the nasal feature is going to surface differently in these contexts than it does in these contexts, and that's basically what complementary distribution is. We're going to get nasal vowels before a nasal consonant, but oral vowels elsewhere. And I've done this at the end of a word, but you could also put an oral consonant afterwards. You could put, I don't even know, another vowel afterwards or whatever. You'd still get the same output in all those different contexts, being determined solely by the fact that we don't like nasal vowels. Now, the winning candidate here with the nasal vowel, pang, that's going to violate the constraint against nasal vowels, but it doesn't matter because context-sensitive markedness is higher ranked and is going to determine the value of that feature in the output. And then finally, we don't really care about the faithfulness constraint at all in this language. That's why we've ranked it low. But this one would favor preserving contrasts if it were higher ranked. In particular, for this one, we're going to need to look at the relationship between input value for the nasal feature and output value for each of the candidates. This one is minus nasal, so if it's minus nasal, we're good. But if it's plus nasal, no good. Input is plus nasal, output minus nasal, that's a problem. Output plus nasal, no problem. This one's oral, minus nasal. This one's minus nasal, no problem. This one's plus nasal, problem. That said, this constraint doesn't make any difference in this particular language because it's low ranked, which is what we'd expect from a language where vowel nasality is not contrastive, which it isn't here. It's allophonic. It's a complementary distribution. So that's the allophony part. And that roughly matches what we find in English, although of course there's a little bit more complexity than that simple description. That vowels are nasal before a nasal consonant and oral elsewhere might make it seem. That's roughly what English looks like. All right, third possibility here, positional neutralization. This is where the feature is contrastive in some context, but non-contrastive in another context. And so what would that look like here? Well, to be non-contrastive in a specific context would mean that markedness takes over in that context. In order for that to happen, you need to have context-sensitive markedness ranked above faithfulness. That's going to neutralize the contrast in this particular set of contexts. But in order to preserve the contrast in other contexts, you're going to need faithfulness to dominate something in the language. And in particular, we're going to need faithfulness here, which again favors preserving contrasts, to dominate the general markedness constraint, the context-free one. So let's reverse these two and see what happens. So faithfulness in the middle here. Ident nasal. And then general markedness, don't have nasal vowels, is going to be low ranked here. So what's going to happen with this ranking? Well, this context-sensitive markedness constraint is going to look just the same as it did in the previous one. It's going to have nothing to say about contexts where there's no nasal consonant. Right? So these are just going to be blank. In the context where we do have a nasal consonant, it's going to take over. Context-sensitive markedness says, well, if you have a nasal consonant, the vowel before it better be nasal. Right? You don't want it to be oral. And so that's going to determine the winner in this specific context. And that's going to be true, again, regardless of whether this vowel is oral or nasal in the input. It's always going to be nasal in the output. So the contrast is neutralized in this particular position to plus nasal. Right? So that candidate where the vowel is oral, the one I can't fit on the board here, is going to look exactly like this one in the highest rank constraint column. The other ones are going to be a little bit different, but they don't matter. You're going to get the same input for both of these. Right? Now with regard to these guys, now what takes over next is faithfulness, which favors preserving contrasts. And so basically, this is just going to say, hey, if you changed the orality or nasality of this vowel, you're out, right? So oral, oral, good. Oral, nasal, bad. Nasal, oral, bad. Nasal, nasal, fine. And this is going to take over in the general elsewhere context where you're not before a nasal consonant. And it's going to favor preserving the input form. If you started out as pa, you're going to finish as pa, or be produced as pa. If you started as pan, you're going to be producing the output pan. You're going to stay faithful to whatever was in that underlying representation. And so what we're going to end up with is contrast in this elsewhere condition, pa, pan, but neutralization of that contrast in the specific context where you're before a nasal consonant, and their vowels are always going to be nasal. Right? So this language has only nasal vowels before nasal consonants, but contrast elsewhere. Right? This last one, don't have nasal vowels, straightforward enough. It's going to mark the nasal vowel in each of these tableaux. But it makes no difference because it's low ranked in the language. These two constraints are going to determine the outputs in every case. So this language, one of the reasons why I didn't use this Kager example as my main example for this section, excuse me, is because it's not clear to me that this typology that he gets out of these three constraints is actually the right typology. Right? So I think there are some languages in the world that pattern this way, that they have vowel nasality contrasts. And there's even languages where there are vowel nasality contrasts that neutralize before a nasal consonant. I'm not sure I know of a language where this neutralizes to nasal before a nasal consonant. So French is the language that I'm most familiar with that has vowel nasality contrasts. This part is definitely right. You get contrasts in the general case in French. But in this context, it's actually almost always the case, at least within a word, you'll find that these vowels are actually oral in French, if you're looking at a word final consonant, unless you put it before another word within a small syntactic phrase that begins with a vowel, in which case it gets kind of complicated. But in general, it's not clear to me that this particular language is really well instantiated by any particular pattern I know of, and Kager doesn't really give an example of how this would work. That said, I'm pretty sure there are some Amazonian languages that roughly conform to this pattern. I'd need to go do some research in order to figure out how accurate that is. But this is one of the reasons I didn't use this typology as my parade example. I'm not sure the typology is actually right. But in a way, in order to figure out what OT is for and what it's doing, we don't even need to know whether the typology is right yet. Of course, eventually we want to have the right theory of typology, but right now we're just trying to look at how does OT do typology, and this example absolutely illustrates that. It also maybe illustrates that typology is hard and it's easy to get it wrong, even with sensible constraints. That said, let's look at the last language here, which is full contrast, or I've called this free contrast. This one is pretty straightforward. In order for a feature to be contrastive everywhere, preserving that feature has to be the highest priority in a language. And the constraint that says preserve this feature is faithfulness. So faithfulness has to be high ranked. And once you do that, it doesn't matter how you rank the other constraints. You can rank them any way you want, but those markedness constraints are never going to be a high enough priority to cause you to change any feature values, because faithfulness is the top priority. And so they're not going to have any effect in this language, in essence. Here's the faithfulness constraint, ident nasal. Here is the context-sensitive markedness constraint. Don't have an oral vowel that's followed by a nasal consonant. And what's going to happen here? Well, in every case, this faithfulness constraint is going to fully determine the output. Input oral vowel, don't change it to nasal. Input nasal vowel, don't change it to oral. Input oral vowel, don't change it to nasal. And the fourth tableau that I couldn't fit here would be like this, but with a nasal vowel, and it would say, don't change it to oral. So in every case here, the output is going to be the same as the input, at least with regard to vowel nasality, right? And we're going to end up with pa in contrast with pan, and pan in contrast with pan. Now, you can also assess the markedness constraints. It's worth doing. I just left these up from last time. Ooh, I also made a mistake here. Oh, no, I didn't. Sorry, that's the context-free markedness constraint, which I forgot to fill in here. Context-sensitive one, again, doesn't apply if there's no nasal consonant anywhere in the word. This just doesn't have anything to say about it. Here, where there is a nasal consonant, it says, let's not mismatch that preceding vowel for the nasality feature. But again, not high-ranked enough to do anything in these tableaux, so we're just going to end up with contrast everywhere. And again, this is definitely predicted by the typology, and it's worth seeing how the typology predicts this in OT. But again, I can't come up with a language that instantiates this pattern. I don't know of any languages that freely allow contrasting oral and nasal vowels before oral consonants and before nasal consonants. I'm not aware of any language that works that way. There might be, but Kager doesn't give an example. And so I find this a little bit worrying. That's why I sort of save this for the end of the handout, and I like my anteriority typology better because I can instantiate each of those language types with a number of different languages. Whereas here I'm much less certain that the typology is right. The important point for this section of the class, however, is just understanding that indeed any three constraints that have this relationship between them, where one of them, they're all referring to the same feature, right? Nasal, minus nasal, plus nasal, nasal. And we have a context-specific markedness constraint that calls for one value for that feature in a specific context. A general markedness constraint that calls for the other value of that feature in the general case. And a faithfulness constraint for the feature. Anytime you have that relationship amongst three constraints, you're going to end up with this particular typology that derives all of the phonological distributions we've looked at so far in this class. Right? So this is going to be a pretty useful property of optimality theory. And that's what this is meant to illustrate. Whether this is empirically correct for vowel nasality is a more complex matter. At a first pass, French doesn't seem to be possible in this typology, which is a problem because we know French exists. Therefore, we're probably going to need at least one other constraint and probably more than that in order to really get a full typology. But the point here is just that we can predict a typology using these constraints, using OT, that conforms or describes many of the phonological distributions that are relevant to the world's languages. And that's the point of the exercise.